yourself, you have just register yourself only once, so you keep on navigate different places, but you have to understand that you send only one. And then you choose the options of all. Then we come to the number 6. Number 6, you say that click playlist. We organize we organize our topics in form of what? In form of playlists. For example, in probability and statistics, in this aspect of learning, we'll be having 4 topics. So each topic will have its playlist. And when it will have its own playlist, that topic will consist of questions. It means that consisting with videos about the particular topic. So for instance, that if you go to playlist and then you have to solve what? You have to find out normal. It means one of the examples of the playlist that you have created is normal distribution, right? So normal distribution. So again, in case that you want to share, we know that you love our contents. Then they ask it for you to share. You can click the icons written share to share video link to your friends via social media, example Facebook, WhatsApp, Telegram, Instagram, email, Twitter, etc., etc., etc. So welcome into our departments of higher engineering and scientific mathematics, and then it's model courses called probability and statistics. And this content is for the second year, BEG or Bachelor in Science, NT level 7, National Technical Award level 7. This is chapter 1 called normal distribution. And then this is lecture 2, which is called normal distribution curve and table 4.4. That's what you're going to learn today, right? So you have to stay tuned. Okay. Do you like to learn, understand, enjoy, and apply the beauty of higher engineering and scientific mathematics? How are you, everybody who is watching this program? I would like to take this opportunity and welcome every national and international into these fantastic programs and welcome into this fantastic moment of learning the beauty of higher engineering and scientific mathematics. My name is Olenjolaim Moko TAYAI Losingo. Simply just call me Olenjolai. I thank God by His own grace. He has anointed me and He has called me to be His national and international teacher of higher engineering and scientific mathematics for undergraduate engineers or for undergraduate students. So I'm very happy to have you, and I would like to ask you I would like to ask you to join me for a few minutes ahead, and because I believe that these sessions is going to transform your life and it's going to answer so many questions and actually open your mind and open your focus on how you can deal with probability and statistics for undergraduate students. So firstly, I would like to welcome you into our online institution that's called Online Undergraduate Polytechnic Institute of Tanzania (OLENJOLAM). Simultaneously, I would like to welcome you into one of our official YouTube channel that's called Online Undergraduate Polytechnic Institute of Tanzania (OLENJOLAM). Well, so I know you have so many questions in your mind, and one of the questions is what the visions of Online Undergraduate Polytechnic Institute of Tanzania. That is very good and excellent questions for the rest of your life, because you have to ask yourself and questions, different system questions, different programs that you are taking in. So simply, I would like just to remind you and just to, if it's your first time, to declare to you the vision that you have in your mind, so that you can know the focus and the directions that we have to take on. This is an assignment that we have been given by the founder and the sponsor of Online Undergraduate Polytechnic Institute of Tanzania. In abbreviations, just we call it OPITO. That's the simply abbreviations of every initial letter in that fantastic institution. So firstly, this is the online institutions. It's not a physical institution, so we used to provide our contents online, and this is our vision, that we have an assignment to teach and train undergraduate students on how they can extract knowledge, understanding, and wisdom from the classroom instructions in higher and scientific engineering mathematics in different core modules or courses of engineering and scientific programs. Okay, so and then after extracting that knowledge, understanding, and wisdom from those from the classroom instructions, then we'll teach you how you can combine with the knowledge, understanding, and wisdom that we are going to teach you to extract it from the Word of God written in the Holy Bible in order to solve real-life problems. So we are here to solve real-life problems and not otherwise. So because we are here to solve real-life problems, so we like to invite you to just to take your procedures and take your measures into this fantastic moment of solving real life problems. So we'll be challenging you, we'll be teaching you how you can think differently and how you have to think outside of the box. Okay, that's a very important moment that you have to take into consideration. All right. So again, you have so many another common questions to most of viewers is, what problems are we solving and how are we going to solve? Well, according to my research that I made for more than 6 years before I began this online program, I have realized that there's so many undergraduate students who are taking different programs in engineering and scientific programs. They used to encounter different challenges and difficulties on how they can master and enjoy the beauty of high engineering scientific mathematics. So I'll be using different teaching aids, different teaching methodology, different teaching aids, different teaching techniques, and different approach on how I will take the advanced, intermediate, and simple concepts and break them into simple and make everything simple, so that faster learner students, they can understand, intermediate learners, they can understand, and even slow learner students, they have to master and understand every content. So that is our main objective and that is our main focus on this program. So we'd like just to invite you to enjoy everything that we are going to provide for the rest of this program. So again, in case that you want, you have to remember that you have to click the buttons of subscribe below in order for you to register yourself permanently. And then we'd like to ask you to be an active learner. So when you say that active learner, we ask you to use the part of the comment sections in order to give us feedback, whether you understand what we are teaching you. And also, you can submit your homeworks, quizzes in the comment section. Later we'll be providing another method or another method of students to interact with us more conveniently compared to the present right now, because now you cannot write the mathematical expressions in the comment sections. But just to keep in touch, and then I will share with you a kind of interesting method of interacting with my students. So in case you have any question, don't hesitate to ask in the comment section, please. And so right now, let us go into today's session. This is, we are in departments of higher engineering and scientific mathematics, and also the course is called probability and statistics. This course in most institutions or colleges under Nacte, because that is curriculums that we are using, especially, for example, the Restaurant Institute of Technology, Arusha Technical College, Beng University of Science and Technology, and other Karume Institute of Science and Technology. They used to cover, or they have to cover these modules in the second year of a Bachelor in Engineering or Bachelor in Science, and this is NTA Level 7. And we are in Chapter 1 that's called Normal Distributions, and today we'll be focusing on area under the standard normal curve from 0 to Z, Table 4.4. And this is a Lecture 3 overview of standard curve, or standard normal distribution, or standard normal curve. Normal curve, or normal distribution. Standard normal curve or standard normal distribution. I'd like also to insist to you that this is the continuations of Lecture 2, because in Lecture 2 I taught you two cases that you can use Table 4.4 in finding areas under the curve or under the normal curve. So just quickly, let me just do the quick review of Lecture 2. In case you missed Lecture 2, you can access in our, and Lecture 2 also give you explanations on how you can access more for our contents, and Lecture 2 also give you explanations on how you can register yourself permanently to be a student of OPITO. So quick review of Lecture 2. So in Lecture 2, simply we say that, or we told you that, first of all, the areas, one of the concepts that we told you that when we talk about area, we talk about probability, okay? And also when we talk about probability or area, we talk about proportion. Okay, so these are the three synonyms words. But again, we say that Table 4.4 is used to compute, or is used or provides, so to say that provides standardized value and corresponding probability. So ladies and gentlemen, welcome to learn about Lecture 3, where I'm going to teach you how you can use Table 4.4, the one that you have, because if you have a physical table, whenever that you are taking these contents, we will insist every student to have a physical table for you to enjoy and master these contents for the rest of your life, right? So make sure that you have a Table 4.4 in order for you to enjoy the beauty of this stuff. So here it is, Table 4.4. So this is the Table 4.4. So how can you use Table 4.4 to find areas under the standard normal curve from negative Z1 to Z2. That's the question that you have. So the first step, we say sketch the standard normal curve from negative Z1 to Z2. Suppose that this is the figure. That's the normal curve. So how can you find the area under the normal curve within that boundary? So that's the first step. The second step, you have to write the probability inequality. Probability inequality. Probability inequality. So we say the second step, we say that write probability inequality. So to write the probability inequality, the area under the normal curve is equal to probability from negative Z1 less than or equal to Z less than or equal to Z2. Right? So area under this normal curve. So this one, we say that mathematically is equal to probability from negative Z1 less than or equal to Z less than or equal to 0 plus what? Probability from what? From 0 less than or equal to Z less than or equal to Z2. So means that you have to take probability of under this or area under this normal curve plus area under this normal curve. Okay? So that's the process that you have to take. Right? So that's the inequality. So remember that, not before I taught you that by using the concepts, the characteristics of the normal curve, which you call all the we say that the normal curve are symmetrical about mean. So it means probability from negative Z1 less than or equal to Z less than or equal to 0. This is equal to probability of 0 less than or equal to Z less than or equal to Z1, but positive. By what? By characteristics of what? Of symmetry. Characteristics of symmetry. Right? So if that the case now, we say that probability from negative Z1 less than or equal to Z less than or equal to Z2, this is equal to what? This is equal to probability of 0 less than or equal to Z less than or equal to Z1 plus what? Plus probability of what? Of 0 less than or equal to Z less than or equal to Z2. So that is the formula. So this is the formula we have to use. Okay. So area under the normal curve, just demanding your level of comprehension. So let us solve example 6. Find the probability of the region lies between negative 3.65 and the 0.49. So find the probability of the region lies between -3.65 and the 0.49. So that is a practical question on how we can use effectively table 4.4 to find area under the normal curve of 40 of these are within that given region. So if this is the case, you say that solution. So the first step, you say that sketch the region under the standard normal curve. So this is our sketch. Okay, so this is 0. So you say that we have negative, suppose that this is -3.65, and then suppose that this is 0.49 positive. So we have been asked to find area under the normal curve between -3.65 and 0.49. So let us shed the required region. Okay, so that's the problem that we have. So this we call the normal curve 3.2. We go for the second step. Second step, we say that write the inequality. So to write an inequality, you say that we are looking probability from -3.65 to maybe to positive 0.49, and this is equal to probability of the first region on the left-hand side of 0 and the probability of the regions on the right-hand side of 0. So say this is probability of -3.65 less than or equal to Z less than or equal to what? To 0 plus probability of what? 0 less than or equal to Z less than or equal to 0.49. Okay, by symmetry. So the third step, we have a problem here. We can read this one directly from table 4.4. So now third step. So we say that by symmetry, we say that probability -3.65 less than or equal to Z less than or equal to 0. This is equal to probability 0 less than Z less than or equal to what? To 3.65. So after having that inequality, then we use table 4.2. Then we use table 4.4. We use table 4.4 to, so the first system. Use table 4.4 to find what? Probability of 0 less than 30 less than or equal to 3.65. And this is equal to what? So probability of 3.65, it's above here. So if you read, that is the 37th column, 37th row, 3.60, and then 3.60, the second decimal place is 5. So 5, so it is here, right? So this value, so the probability is equal to what? So the probability is equal to 0.499. 0.499. So it's 0.499. 0.499. So that's the probability corresponding to Z is 3.6, and then the second decimal place is 5, right? I haven't shown, I didn't show it there. So simply it means that this is, suppose that this is 3.6. So the probability that you are looking for is 0.499. 0.499. So again, you have what? Probability from 0 less than 30 less than or equal to what? Or equal to 0.49. 0.49. So 0.4, this is 0.4, right? So this is 0.4. And then the second decimal place is 9. So in the 11th column. So the corresponding probability, if you move from here and then you move horizontally, it will be 0.1879. So 0.1879. Remember that for the probability of the negative, so remember that this one is equal to probability of, remember, probability from 0 to 3.65 is equal to probability from negative 3.65 to 0. And don't introduce negative because probabilities are always positive. Bear that in your mind. So then we say that from this equation, so suppose that this is equation 1. Okay, that is equation 1. So the fifth step, okay, so suppose that this is equation 2 and this is equation 3. So the fifth step, we say that substitute equation 2 and equation 3 into equation 1. So if that the case, you say that probability from negative 3.65 less than or equal to Z less than or equal to 0.49, this is equal to what? 0.4999 plus 0.1879. Okay? So this will make what? 9 plus 9 is 18. Keep 1. Then you have 8. 8 plus 9 is 17. Then you keep 1. Then plus 1 is 10. Then this is 18. Then you keep 1. Then 1 plus 4 plus 1, it is 5. So 0.5878. Alright? So therefore, we say that therefore probability of what? Of negative 3.65 less than or equal to Z less than or equal to 0.49. This is equal to what? Is equal to 0.5878. So that's what we have asked you to find. And that the response, 18, keep 1, 18, keep 1, Now 17, keep 1, 18, keep 1, 6. This is wrong. Because you keep 1, 4 plus 1 is 5, plus 1 is 6. So this is 6. So that's the response. So it is 0.6878 at the response for the given probability. And that is all about jotting. That's all about in case 3. So right now, let me teach you case 4. Case 4, the use of table 4.4 on finding the probability as case 4. So use of table 4 so use of table 4.4 to find areas or probability under standard normal curve from steady to positive infinity. So the first stage of using table 4.4, the first step you say that sketch the standard normal curve. So to sketch the standard normal curve, the standard normal curve, and then have a sketch from what? From Z to positive infinity. Okay? So we have to deal with area under the standard normal curve. And the standard normal curve. So this is equality normal. Ladies and gentlemen, I would like to welcome you into case. This is case 4. And this case 4 is titled as what? Use of table 4.4 to find areas under the standard normal curve from Z to positive infinity. So the first step, we ask you to sketch the standard normal curve, and this is our standard normal curve, where we like to find the area under the curve from Z to positive infinity. So this is the first step, implementations of first step. The second step, we ask you to write an inequality. The inequality of this probability, we say that probability of Z greater than, so suppose that this is Z1, so from what? From Z1 to distinguish Z1 with Z. So probability of Z greater than Z1. So how do we find this probability? Why the table 4.4 just to give us the probability from Z is equal to 0.00 to Z is equal to 3.99. How can you use that table? Well, so the inequality here, remember the concept of the symmetry. We say that all the normal distributions are symmetry about the mean. So this is the mean, so this is 0. So this is the line of symmetry. Remember also total area under normal curve is equal to 1. So because it's the line of symmetry, the area under normal curve from what? From negative infinity. So ladies and gentlemen, the second step we have to write the inequality of the probability. So, and the inequality state that probability of z greater than or equal to z1. This is equal to 0.5 minus probability of 0 less than or equal to z less than or equal to z1. The third step, we have to use table 4.4 to find the probability from 0 to z1. So we have to use table 4.4 to find probability between 0 and z1. So the unshaded area from 0, z is equal to 0, to z is equal to z1. Right? So you can use table 4.4 to find this probability. And then the next step now to find this one, so you just have to subtract. Okay? You have just to subtract. So that is the concept. And whenever you encounter a problem, the weighted problems in probability that ask you to find the area, the normal curve of this case, then that's the simple, although these are the 3 steps that you have to follow for you to solve the problem. And then just enjoy the beauty of probability in statistics. Okay? So then we say that then our interest or our responsibility to find probability from what? From probability of z greater than or equal to z1. And this is equal to 0.5 minus what? Probability of what? Probability of 0 less than z less than or equal to what? To z1. So, ladies and gentlemen, let us solve example 7. So find the probability of the normal curve lies between curve of the normal curve which is greater than, so I say that of the normal curve with standardized value greater than 1.2. But I think that's the best way, okay? Yes, 1.2. Yeah, so let's say 3.8, because I want to use the table that I gave you. 3.8, 3. So I have a responsibility to find the probability of the normal curve with standardized value greater than what? 3.83. Solution. The best way to solve this problem, we have to say that the first step, you have to follow the steps. This is all about case 4. So the first step, we have to sketch the problem on a normal curve. So this is 0. And suppose that you're looking for 3.83. But the conditions is greater than. So because the conditions is greater than, so this is the area under the normal curve that we have to find. So this is normal curve 3.4.5. So that is 3.4. Okay, and this is that is equal to 0. Okay, if you join me right now, you are welcome. We're enjoying the lecture series of probability and statistics or of normal distribution that called you the overview of standard normal curve, table 4.4. Right? So then here is second step. So the second step, we say that, okay, that's the first step. The second step, after sketching the normal distribution curve, then we say that, write inequality. Write inequality. So write inequality, we have probability of what? Of z greater than or equal to 3.83. Remember that this is also equal to what? Probability of z greater than what? 3.83. So whether you use the word greater than or equal have the same meaning, right? So how can you find this probability? As I told you, this line here we have a normal distribution curve, and this is the mean. So this is the symmetry. So the area from z is equal to negative infinity to 0 to z is equal to 0 is 0.5, and the area from 0 to z is equal to positive infinity is equal to 0.5. Right? So if that's the case, you say that this is 0.5 minus probability of what? So it means that from the probability from 0 to positive infinity is 0.5. Remember that. Okay? Simply say that. In other words, say this is equal to probability from 0 less than or equal to z less than or equal to positive infinity minus what? Probability from 0 less than or equal to z less than or equal to what? Or equal to z1. Means 3.83. Simply, probability of z greater than 3.83. This is equal to 0.5 minus probability of 0 less than z less than what? 3.83. So we say probability of z greater than 3.83 is equal to 0.5 minus what? Okay, so now so here the third step. Third step, use table 4.4. Find probability of 0 less than z less than 3.83. So here it is table 4.4. The first decimal place is 3.8, this one. And then the second, or the column, second decimal place is 3. So the line of intersection is this one, 3.8. So it is 0.499. So therefore, probability of z greater than 3.83 is equal to 0.5 minus 0.499. What will be the response? probability of z greater than 3.83, this is equal to what? So we have 0.5000 minus 0.4999. So this is equal to 1, then 0. So you have 1, 10 minus 9 is 1, 9 minus 9 is 0, 9 minus 9 is 0, 9 minus 9 is 0. So it's 0, 0, 0, 1, this is 0. So probability of z greater than 3.83 is equal to 0.001. Okay, so that's the response. So therefore, this is the response of the questions which have been given. And that's the way that you will be dealing with all the problems, all the related problems, like what are presented in case 4. So ladies and gentlemen, let me teach you case 5. And then case 6 and case 7, we encounter them when we'll be solving problems. So case 5, use 4.4 to find area under standard normal curve from negative infinity to 31. So always the first step, we say that sketch there, standard normal curve, sketch the standard normal curve, sketch the standard normal curve from negative infinity to 31. So this is 0. Then suppose that this is Z1. So let's say to negative Z1. So this is the area of the normal curve. So this is normal curve. Normal curve 3.5. So how can we find this normal curve? Well, table 4.4 gives us only probability for positive value of it. Okay, so that's the first step. So second step, we have to write out the inequality of probability. So what is required? We are looking probability of Z less than or equal to negative Z1. How can we find it? Okay, we have alternative. The first alternative is we can find probability from negative infinity less than, let's say, less than or equal to Z, less than or equal to what? To 0. Then we subtract this probability of unshaded region from negative Z1 less than or equal to Z less than or equal to 0. Okay, so if that the case, if that the case, we say that, if that the case, so also we know that, but probability from negative infinity less than or equal to Z less than or equal to 0, this is equal to what? 0.5 due to the symmetry, because the total area under normal curve is 1. So the total area from 0 to negative infinity is 0.5, and total area from 0 to positive infinity is 0.5. Again, from the symmetry, we say that probability from negative Z1 less than or equal to Z less than or equal to 0, this is equal to probability of what? Of 0 less than or equal to Z less than or equal to Z1, positive. So if that the case, you say that now probability of Z less than or equal to negative Z1, this one is equal to 0.5 minus what? Probability of 0 less than Z less than or equal to what? Z1. So we go for the steady state. Steady state, we say that use 4.4 find probability from 0 less than or equal to Z less than or equal to positive Z1. Then you substitute in the geometry quotient and you find the response. Example 8. So example 8, we say that find area under the standard normal curve lies between or lies, okay, curve whose value is less than negative 0.44, because we want to use this table. Okay, so solution. Solution. So the first step, say that sketch So to sketch the normal graph for this problem, we have our bell-shaped D. This is 0. So this is negative 0.44. Okay. Okay. So the second step, right? Inequality of probability. Okay. So the inequality of probability, you have to find probability as z less than negative 0.44. So it means that this is equivalent to a probability of what? From negative infinity to negative 0.44. So if that's the case, we say that, okay, fine. This will be equivalent to what? This will be equivalent to probability, as I told you. It means the probability from negative infinity to 0 is 0.5 minus what? Probability of unshaded region. So probability from negative 0.44 less than 30 less than 0. Right? But remember that from the concepts of symmetry, we say that probability from negative 0.44 less than 30 less than, so less than 30 less than 0. This is equal to what? Probability of 0 less than 30 less than 0.44. So if that's the case, you say that probability of 30 less than negative 0.44, this is equal to 0.5 minus what? Minus probability of 0 less than 30 less than 0.44. So this is equation 1. How to use table 4.4 to find the required probability. So third step. So we are done with the second step when we found this equation 1. Probability of z less than negative 0.44 is equal to 0.5 minus probability of 0 less than z less than 0.44. And that is question 1. And then we say that, okay, the third step we have to use table 4.4 to find probability of 0 less than z less than 0.44. By using the concept of the symmetry, if you do remember. And then, so by using table 4.4, we found a probability from 0 to 0.44 is equal to 0.1700. So the first step, we have to substitute equation 2 into equation 1. So this is known, this is unknown. So after substituting, then we do the subtractions operation. So 0.5 minus 0.17 is equal to 0.330. So the probability of z less than negative 0.44 is equal to 0.33, and that's the response. Okay. That's all about 20 example A. So example 9. Refer DIT, Dar es Salaam Institute of Technology, Test 1 of academic year 2014 and 2015. Question 1. A. If X is normally distributed, and this is concept, it's normally distributed with mean of 30 and the standard deviation of 5. Find number 1 probability as 26 less than or equal to x or less than or equal to 40. Number 2 find the probability absolute x minus 30 greater than 5. This is 5 marks. So if x is normally distributed with mean of 30 and standard deviation of what? Of 5, find probability of 26 less than or equal to x less than or equal to 40, and number 2 find the probability of absolute x minus 30 greater than 5. If you do that, you have a gift of 5 marks. So it's a concept question. We'll be using the standard normal distribution curve, table 4.4, on solving this problem. But we have to do some simplification first before we use table 4.4. Solution. The first step, we say that find Z for 26 less than or equal to x less than or equal to what? Z for what? For x1 is equal to 26. So we say that you have to record the formula, find the standardized normal value. Z is equal to statistical value x minus mean of a standard deviation. So this will be Z1, which will be corresponding to x1, which is equal to 26. So 26 minus mean, what the mean of the distribution. So mean of the distributions will be given is equal to 30. And then the standard deviation, which is sigma, which is a Greek letter, is equal to 5. So it's equal to 26 minus 30 divided by what? By 5. So 26 minus 30, this is equal to -4 over 5. So So simply, this is equal to negative 0.2 in decimal places, 0.4. Why 0.4? Because it means that 40 over 5 are negative 0.8. Because 8 times 5 it is 40. So negative 0.8. That is Z1. So find Z1 for that one. So the second step, we say that let us find Z2 for x2 is equal to what? For x2 is equal to 40. So we say that we are looking at Z2 is equal to x2 minus what? Mean, which is common, over standard deviation. So x2 is 40 minus what? Mean, which is equal to what? 30 over standard deviation, which is 5. So 40 minus 30, it is 10 over 5. The response is equal to what? To 2. Why should we find the value of standard normal variable z? Because remember, table 4.4, which will assist us to get the area under the curve according to the given condition, is well defined as with two variables. The standardized normal variable z, which is come from the random in most cases that it comes from random continuous variable, and the probabilities. So in this case, we are given the statistical value, which is x. We have to use the statistical value x to find the corresponding value of z. So being given in interval, it means from this to this one, we cannot, first of all, we don't have the values of 26 and 40 in the normal distribution table. Remember, the range of values of z in the table 4.4 is from 0 to 38.9, or from negative 38.9 to 0. Remember that. So now we have our corresponding variables. So that's the first step, and this is the second step. So that's the case. So we go for the third step. The third step, we say that sketch what? Sketch the standard normal curve. So sketch the standard normal curve. So it is structure, remember that it is bell-shaped structure. So you might find that sometimes the symmetry is not the same, but this is the meaning of sketch. So we say that the first the 2, corresponding value of the 2 is 2, and then the corresponding value of the 1 is negative 0.8. So this is normal curve. Let's say this is 3.5, if I'm not mistaken. So we've been asked to find the area under the normal curve from negative 0.8 to 2. Okay. So if that the case now, we go for the first step. First step, we say that the right, the inequality of probability. Okay, write inequality of probability. So the inequality of probability, for that case, we have to look the probability from what? From Z1 less than or equal to Z less than or equal to what? Z2, and this is equal to what? Probability of negative 0.8 less than or equal to Z less than or equal to what? Equal to 2. That's what you have to find. And this one is equal to what? Probability from negative 0.8 less than or equal to Z less than or equal to 0 plus what? Probability from 0 less than or equal to Z less than or equal to what? To 2. That's a fact. So suppose that this is equation 1. But we say that probability by the symmetry, by the concept, probability from negative 0.8 less than or equal to Z less than or equal to 0, this is equal to what? Probability of what? Of 0 less than or equal to Z less than or equal to 0.8. So we have to go to the first step. First step, we say that use table 4.4 to find what? Probability of what? Of 0 less than 30 less than or equal to 0.8. So take your table, because I didn't show that column. So 0.8, remember that the second decimal place is 0. So take your table 4.4 and then use it effectively to find the area under the normal curve. So just to go to first, second, third, fourth, the fifth, sixth, seventh, eighth, to the 8th row and the second column. So the corresponding probability is 0.28, 0.2881. So less than 0.80, this is equal to 0.2881. And also find the probability from 0 less than 30 less than or equal to 2. So this is corresponding to 2.00. So because 2 is a whole number, it's 2.00. So you have to go to trans, to the trans what? To the trans row, because 1, 2, 3, 4, to the trans ones row. And the second column, so the corresponding probability is 0.47, 0.4772. So this will make equation 2, and this will make equation 3. So the sixth step and the last step, we say that substitute equation 2 and equation 3 in equation 1 above. So the equation 1 states that probability from negative 0.8 less than or equal to z less than or equal to 2.00 is equal to what? 0.2 0.2881 plus what? 0.4772. So we say probability of what? From negative 0.8 less than or equal to z less than or equal to 2. This is equal to what? 1 plus 2, 83. Then 8 plus 5, now 8 plus 7 is 15, keep 1. That is 8 plus 7. 8 plus 7 is 15 and 1 is 16. So we still have 1. 2 plus 4, it is 6. Plus 1, it is 7. And it is 0.7653. So 3, 15, 16, 7. So this is the response. So therefore, probability of 26 less than or equal to x, not y, less than or equal to 14 is equal to 0.7653. You can also use the scientific calculator function 900 into 1 to evaluate these probabilities, but it's not a great deal. So this is the answer for Roman 1, right? Okay, I'm about to finish this session or the lecture study. So we have solution to example 8 or 9, 1, 2, 3, 4. So example 9, Roman 2. So we have been asked to find out the probability. So let me do this one, then I'll do the homework for you. So we will be given probability of absolute as x minus what? X minus 30 greater than 5. So the first stage, we say that we have to simplify. How to simplify the given problem. Probability as absolute of x minus 30 greater than 5. How? So remember that, recall the fact that absolute of a, let's say, it's less than, or we say that greater than, whatever the case. Let's say that greater than what? So absolute of a greater than, let's say, 10. So this one means absolute is plus or minus of a greater than what? 10. So if you consider positive, it means you have positive a greater than 10. And also if you consider negative, you have negative a greater than what? 10. So a divided by negative to both sides. So you find that also a is less than negative 10. This is the fact. So similarly, if you have absolute of x minus 30, if you don't understand for clearly this approach in the first process, review this lecture or review this part several times so that you may understand. So if that the case, you say that because this is the absolute sign. So we say we have plus or minus of x minus 30. This is greater than 5. So consider positive. So say positive x minus 30 greater than 5. So this is x minus 30 greater than 5. Make x the subject. So minus 30 plus 30 greater than 5 plus 30. So x greater than 35. That is if you consider the positive sign. If you consider negative sign, we're still in simplification of the given problem. If you consider negative sign, you say that you have what? You have negative x minus 30 greater than 5 divided by negative 1 divided by negative 1. So x minus 30. So the sign has to change if you divide this negative. So it is negative 5. Okay, so we have to change the sign of the inequality because we're divided by negative. So if that the case, you say that x minus 30 plus 30 less than negative 5 plus 30. So x is less than what? Negative 5 plus 30, it's what? It's 25. Okay, so x is less than 25 and your x is greater than 35. So you have to be careful with this problem. So second step, we say that now probability of absolute of x minus 30 greater than 5. This is equivalent to write that probability of x less than 25 or x is greater than what? Let us start with this one. X is greater than 35 or not or, and what? And x less than 26. So that's the inequality. Why? Because remember that x less than 25 is left hand side of the standard normal curve. X greater than 35 is right hand side. Why? Because the mean of the distribution is 30. So 35 is on right hand side, while 25 is on the left hand side. So this is the concept. This is mean. Mean is equal to 30. So here we have 35, x is equal to 35, and here we have x is equal to 26. So remember that this is less than and this is greater than. So these regions between 26 and 35 is exclusive, right? So you have to find probability of x less than 26 and x greater than 35. So that's why we say that this is probability of x greater than 35 and x less than 26, right? So if that's the case, we say that again we can keep on writing our inequality. So this is equal to probability of x greater than 35 plus probability of x less than 26. So we go for the third step. Third step, you have to find 31 for corresponding for x greater than 35. You have to record what? So that is the value x minus mean of a standard deviation. So the value of x is 35 minus 30. Standard value is 5. This will make 1. Because 35 minus 30 is 5. 5 over 5 is 1. And then so that is the 1. The 2. So the 2, we have what? X2 minus mean over standard deviation. So X2 is 26 minus 30 over 5. The response is what? Negative 4 over 5. So this is negative 0.8. So we have our corresponding values of Z. About to end lecture 3, and I will leave the homework for you. And the homework will be relating to example 9. It will make 10 examples, but I've solved it for you. So we say that if that the case, we say that probability of x greater than 35, simply this will be probability of z, this equal to z1 greater than 1. Also, probability of x less than 26, this is equal to probability of z2, which equal to z2 less than negative 0.8. Okay? So if that the case, we go for the first step. The first step, we have to sketch out the normal curve. So let us sketch the normal curve. So the normal curve. So to sketch the normal curve, okay, this is z is equal to 0. Then here we have negative 0.8, and there we have 1. So we have to find area under the normal curve. Area under the normal curve, here we have 1. So this is, we say that normal curve 3.6. Okay. Oh, excuse me. This is wrong. I made a mistake, excuse me. So this is the print, and this is the print. So greater than 1, you have to find area under this curve where we are shading, and then so you have to find also area under this curve. So the fifth system. So we say that find probability of z greater than 1 and probability of z less than negative 0.8. This is equal to what? Is equal to probability of z greater than 1 plus probability of z less than what? Negative 0.8. But
We can use table 4.4 to simplify life. We may use a scientific calculator as a statistical function to find this, but we are required to use table 4.4. Okay. So from probability of z greater than 1, probability of z greater than 1, this region, is equal to probability from what? 0 less than z less than positive infinity minus probability of 0 less than z less than 1. Probability from 0 to positive infinity, is 0.5. So you say that probability of z greater than 1 is equal to 0.5 minus probability of 0 less than z less than 1. So this is, suppose this is equation 1, and suppose this is equation 2. Then we say that also from the symmetry, probability of z less than negative 0.8, this is equal to what? Probability from negative infinity less than z less than negative 0, no, less than 0, minus, so probability from negative infinity to 0. So minus what? Minus probability from what? Probability of negative 0.8 less than z less than 0. But we say that probability from the symmetry of negative 0.8 less than z less than 0, this is equal to what? Probability from 0 less than z less than 0.8. So if that's the case, you say the probability of z less than negative 0.8, this is equal to 0.5. Why 0.5? Because the total area under the normal curve from negative infinity to 0, it's 0.5. So minus probability of 0 less than z less than 0.8. So we go for the 6th step. Okay? So this is equation 3. So the 6th step, you say that substitute equation 2 and equation 3 into equation 1. Into equation 1, into this equation. So you say that probability of what? Probability of z less than negative 0.8 and probability of z greater than 1. This is equal to what? Is equal to 0.5 minus probability of 0 less than z less than z and less than 1 plus what? Plus 0.5 minus probability of 0 less than z less than 0.8. So 7th step. 7th step, say now let us use table 4.4 to find what? Probability of 0 less than z less than 1. This is 1.00. So take your table and then read the probability of 1.0, which is 11th row. 1.00. So the probability is 0.34. Probability is 0.3413. Then use table 4.4 to find also probability of what? 0 less than 30 less than 0.8. This is equal to what? It's 0.28, 0.2881, 0.2881. Okay, so we have those values, then we can find the area under the normal curve, which it is what? Probability of 30 less than negative 0.8 and probability of 30 greater than 1. And this is equal to what? 0.5 minus what is 0.34, 0.3413 plus 0.5 minus what? 0.2881. So therefore, probability of absolute of x minus 30 greater than 5 is equal to what? If you do your computation, wait a moment. I made a mistake. The x2 is 25. So not. The x should be less than 25, not 26. So do that correction. So if you take 25 minus 30, it equals negative 5 over 5, it is negative 1. Oh. So I think that I've made so many mistakes. Yes, because I didn't delete. So the 2, so for this case, the 2 will be negative 5 over 5, which is negative 1. So this is negative 1 also. It's negative 1, excuse me, negative 1.00. So this is negative 1.00. This is negative 1.00. Then this is negative 1. This is negative 1.00. This is negative 1.00. This is negative 1.00. So this is positive 1. So this is -1. So this is negative, so this is +1. And then it's +1. So they have the same probabilities. It is 0.3413. So even this one, Z less than 1. I thank God for this correction. So 0.3413. So simply this is 1 minus what? So the response now is 0.3174. Because it is 1, so 0.3174 are the response of this question, which is example 9, 1 and 2. Okay, so ladies and gentlemen, get prepared right now. I would like to give you example 10, which is conceptual, or which actually will test your understanding on this concept of inequalities. So, ladies and gentlemen, this is homework 3, and it's example 10. So, example 10, and example 10, example 10. So, question say refer or X. Let me just write, because I know some students X is normally distributed. So X is normally distributed with mean of 30 and the standard deviation norm, and the variance of 25. Find Roman 1 probability of absolute of X minus 20 less than what? Less than 10. Roman 2, find also probability of X greater than 45, and the find probability of X less than 45. No, less than 40. So, ladies and gentlemen, this is the end of lecture 3, which titles as Overview of Standard Normal Curve, Table 4.4. I thank God who have created me in His own image, and I thank God who have given me this special calling of being a teacher and engineer in electronics and telecommunication engineering, or in just electrical engineering field. And I thank God by His own grace who have prepared me, who have been with me during the preparations of this lecture 3. And I thank God who have given you opportunity to learn these contents. Please tell us in the comment section that you are enjoying this content, from which institution, from which college, which year are you, how did you find these contents helpful for you, and give us a feedback in the comment sections whether you have understood and think how
think outside the box or outside the class how you can apply this information to apply real life problems. So I ask you and I insist and remind you, please subscribe into our channel because we still have so many lectures. This is just lecture 3 of normal distributions. I would like to invite you in lecture 4 when I will teach you about word problems, how you can solve word problems of probability or of normal distribution. So it means that the lecture 4, lecture 5, lecture 6, and possibly lecture 7 will be problem solving. So I have more than 10 questions. I have more than 10 questions of Roman from A to F or from A to G, right? Questions which are conceptual questions, and I will be teaching them and will be applying and using the table 4.4. So when you join me in lecture 4, don't forget to have your table 4.4 as one of the reference and useful material for learning normal distribution. So keep enjoying the beauty of probability and statistics. Invite some other students, share these contents, like these contents, ask your questions in the comment section, submit your homework in the comment section. In case you find any challenge or you didn't understand any part of this lecture 3, please ask in the comment section and I'll be there to help you to make sure that you understand, enjoy, and apply these concepts in solving real-life problems. So this is Olenjolaim from Tanzania, and I love you so much, and may God bless you abundantly. Join me in lecture 4 of probability and statistics in the topic of normal distributions. Visit our playlist of normal distribution, and also make sure that you keep on loving the beauty of high engineering and scientific mathematics. So don't miss the next session. May God bless and keep you until we meet.